Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்கள். எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Good afternoon students, and today topic is thermodynamics. It is very important topic in physical chemistry. What is the topic name? Write down. Thermodynamics. Thermodynamics. In thermodynamics, in every year NEET exam, they given two questions and very easy numericals they are asking, either sometimes very simple graphs, either whether spontaneous or non-spontaneous, like this reactions are asking. Now in thermodynamics, what is thermodynamics? Thermodynamics is the branch of science which deals with energy changes in physical chemical process. Thermodynamics is the branch of science which deals with energy changes in physical and chemical process. Now thermo means heat in motion, What is the importance of thermodynamics? It can be applicable, thermodynamic laws are applicable to macroscopic systems, not microscopic. Microscopic means atoms, molecules, ions. It can be explained by it will be explained by chemical kinetics. Rate of reaction can be explained on molecules, ions. But here it is applicable to macroscopic systems, whether it can be explained feasibility of reaction, and whether it is the process is spontaneous or non-spontaneous. Thermodynamics means heat, it changes different forms, means energy in the form of heat energy, work energy. Now whether spontaneous or non-spontaneous. Spontaneous means there is no external agent is required, it is natural process or spontaneous. Non-spontaneous means external agent is required. And another important, whether feasibility of reaction whether is performed or not. Next, it can be applicable to macro systems and heat in motion. Thermodynamics means heat in motion. What are the gas process? The gas process are present now. The gas process, important gas process, one is pressure, volume, temperature. Next one, internal energy, entropy. Next, enthalpy and Gibbs free energy. What are the gas process? Pressure, volume, temperature, internal energy, entropy, enthalpy, Gibbs free energy. These are the important gaseous process. In thermodynamics, we can discuss important introduction, system and surrounding. System plus surrounding is equal to universe, right ma? System plus surrounding, that is equal to universe, means universe contain system plus surrounding. What is the system? System means any specified portion of the universe. Any specified portion of the universe is called as system. Now I am taking in a glass, I am taking one glass, inside some water I filled. I study the inside the glass. I am taking one glass now. Inside the glass, I am investigating this part under investigation, part under, write down, investigation, and this part is I am interested, this part is I am interest, and some calculations also present, calculations. This is called system. What is system, student? Any specified portion of the universe is called as system. I am taking this one simple, I am taking one glass of water. Inside glass I am studying. Inside glass. That is the part under investigation. That is called system or interest. For example, one person more interested in crystal study. That is called crystallographer. If you some students or some persons are interested in chemical process, chemical process means a chemist is interested in chemical process, and in physical process, physicist can interested in physical process. This is called as system. Even plants, animals, human being also one of the system. What is the system? I mean plants and animals and human being. This is also one of the system. This human body also one of the system. In this system different systems are present. Now here is part under investigation and part interest. Any specified portion of the universe is called as system. Now what is the surrounding? Surrounding means the remaining portion of the, I am taking another here. What is the surrounding? Inside is system is present. This inside is system is present, and surrounding means this one is the total surrounding. What is surrounding? Except to system, remaining portion of the universe, remaining portion of the universe is called surrounding. This is the system, outside is the surrounding. Now which one is separate system and surrounding? Which one is separate system and surrounding? The boundary, this is the boundary. Boundary can separate system from surrounding. The boundary means the glass walls. The glass walls are the generally boundaries, but in boundary is real or imaginary. This can be real or imaginary. Next one, it will be real or imaginary, and it will be flexible. It is flexible or rigid. The boundaries are real or imaginary, or flexible or rigid, and this is called a boundary. The boundaries are again divided into one is the diathermic, next one is adiabatic. In adiabatic there is this boundary. Adiabatic boundary means not exchange heat from system to surrounding. That's why delta Q is equal to 0. Now in a diathermic means heat exchange from system to surrounding. What is diathermic? Diathermic means heat exchange from system to surrounding. That is called diathermic boundary. And based on matter and energy transferred from system to surrounding, the systems are classified into three types. What is the based on which property we are explaining? The based on energy and matter transferred from system to surrounding. The systems are divided into three types. One is open system, one is closed system, another one is isolated system. Write down, the systems are classified into open system, one is open system, next one is closed system, another one is isolated system. These are the, we can discuss three in thermodynamics. First one is open system. We open this system means you take one bowl or one vessel. Here you take water inside in the bowl and heat on the burner or stove, anything. If keep on heating, what is happening? The water converted to water vapor, and water vapor is escaping. Matter and energy transferred from system to surrounding. What is open system? And mass. Mass means matter or mass plus energy. Energy. What is the energy? Heat energy or work energy. Heat or work. Mass and energy, matter and energy transferred from system to surrounding. System means inside. This is the inside system. This outside is the surrounding. Now transfer of matter and energy from system to surrounding is called open system. Open system, what is the allowing? Mass and energy. That is called open system. Example, we can take in a vessel, the water is heating. It can be open vessel, not closed vessel. If you taking closed vessel, I am taking closed vessel, here is closed vessel, and this boundary is made up of diathermic. This boundary is made up of diathermic. Diathermic boundary means heat exchange from system to surrounding. If this part is closed means if you are heating the water inside closed vessel, if you are heating continuously, but here is what is happening. Here is only energy, heat can be exchanged from system to surrounding, not matter. Matter is not exchange, only, and heat energy transferred from system to surrounding, that is called closed system. In boiling the water or hot water in closed vessel, what is happening? Actually matter is not transferred, matter is not exchanged, only energy is transferred from system to surrounding. This is called closed system. If you take isolated system, the boundary is made up of, that is adiabatic. The boundary is made up of adiabatic boundary, isolated adiabatic boundary. Here is delta Q is equal to 0. The heat is, and here what is happening? The coffee present in thermos flask. The example is isolated system means coffee or tea present in thermos flask. Here what is happening? In this is the closed vessel only, but the boundary is isolated adiabatic boundary. Adiabatic boundary, what is adiabatic? Heat is not exchanged from system to surrounding. Even neither energy nor matter transferred from system to surrounding. That is called isolated system. What is isolated system? Neither matter nor energy transferred from system to surrounding. That is called isolated system. Here is energy is not transferred. Energy is not transferred. Even next to matter also not transferred from system to surrounding. That is called isolated system. Open system, it can be matter and energy can, and but in closed system only energy is transferred from system to surrounding, not energy transfer, but matter is not transfer. Matter is not transfer. That is called closed system. In isolated system, neither energy nor matter is transferred from system to surrounding. Next one is state function, path function. What is state function? State function and path functions. Right? State function means thermodynamic properties. Thermodynamic properties whose values depends on initial and final state of the system. That is called state function. It is independent on path. It is independent on path. What is state function, students? Thermodynamic properties whose values depends on initial and final state of the system. It is independent on path. Okay na? Now what are the state functions? The state functions are, right, pressure is a state function, P. Next, temperature and T. Next, volume V. Next one is enthalpy, entropy, that is S. Enthalpy H. Next, internal energy U R E. Next, Gibbs free energy the Gibbs free energy means G. These are the state functions. They depends on initial and final state of the system. For example, if you take pressure versus volume graph, the Boyle's law, here is this one is A and this one is B, and this is the one of the, this is initial state, this is the final state, this is the 1 and this is 2. Now the state function depends on initial and final, not depends on path, independent on path. In any cyclic process, please remember this one, pressure versus volume, initial state and final state. It is state function depends on initial and final state of the system, not depend on path of the reaction and path of the process. Now next one is in pressure, temperature and Gibbs free energy, enthalpy, entropy, we cannot absolutely determine. Absolutely determination is, it's impossible, absolute determination, but change in entropy we can determine, change in internal energy, change in entropy, change in Gibbs free energy, change in enthalpy, change in enthalpy. In cyclic process, all in cyclic process, pressure versus volume, in a cyclic process, cyclic means it is a original position when the reaction is started here, again coming to this place, that is called cyclic process. In any cyclic process, the state function, the change of state function is 0. These all are 0. In any cyclic process, change in state function, change in state function is 0. We cannot determine the absolute values of delta U, but we can determine delta U is equal to U final minus U initial. If you write delta S also, and S final minus S initial we can write it. Next, if you write delta G also, and G final minus G initial we can write it. But the absolute of entropy, enthalpy, Gibbs free energy, it is difficult to correct determination, but we can determine the change in internal energy, change in entropy, change in Gibbs free energy we can find out. This is called state function. What is state function, student? The thermodynamic properties whose values depends on initial and final state of the system, that is called state function. Next one is the path function. What is path function? The thermodynamic properties depends on path of the process. Right, path function. What are the path functions? The path functions are heat. The path functions are heat and work. It can be denoted as small letter Q and W. Q and W, heat and work. The thermodynamics, TD, thermodynamic properties, whose the thermodynamic properties are depends on path of the process, that is called path functions. What are the path function? Heat and work. It can be denoted as small letters, not capital letters, Q and W. The thermodynamic properties are depends on path of the process is called as path functions. These are called path functions. Next one is the thermodynamic process. What are the thermodynamic process? And next class we can explain thermodynamic process. Please keep on watching my videos and subscribe it and comment it, like it and share it. Thank you.